Okay, hello everyone and welcome back. Guys, this is the second part of permutations and combinations. Again, just to remind you, today's objective, again, we're going to define and count permutations and combinations, okay? Today's essential question, again, how do we count the number of possible arrangements or the number of possible groups? All right, just to review again. In the first video, we talked about permutations. And they're an arrangement of some or all objects of a set in some specific order. In a permutation, order does matter. And again, remember, we looked at this example of runners in a race. 6 runners in a race. How many different arrangements were there for the runners to finish first, second, or third? So we did a permutation because order did matter there. First, second, and third. That's a permutation. But suppose we're running a race, it's a qualifying race. There are 6 runners in the race. And the top 3 finishers move on to the next round. It doesn't matter what order they come in. Just the top 3 finishers. Well, how many possible groups of 3 runners can move on to the next round? As I listed them right there. There's 20 different ways. Those are just groups. Order doesn't matter. All right, when I list 1, 2, 3, that takes care of 1, 3, 2, and 2, 3, 1, and 2, 1, 3, and takes care of all of them. It's just a group 1, 2, 3. Doesn't matter the order. There's 20 ways to do that, okay? Remember back up here? Our answer was 120. There was 120 ways if order mattered. But in this case, in the qualifying race, order doesn't matter. There's only 20 ways because order doesn't matter. Because each one of these different groups of 3, there are 6 permutations for each one of those. That's why up here we ended up with 120 possible ways. Okay, here order doesn't matter. All right, that's a combination. This counting method is called a combination. It's a very similar formula. All right, where the n factorial is on top and the n minus r factorial is on the bottom. The only other thing that we add in there is another r factorial underneath. And remember, I'm going to go back up to the example. R in this case is 3. And 3 factorial is 6. 3 times 2 times 1. And remember, each one of these groups of 3 has 6 permutations. So we have to divide the 120 that we got here by 6 to get our answer of 20 for the combination. Again, this is a permutation, 120. This is a combination, only 20. The difference is a division of 6, and that came from the r factorial that we added onto the bottom there. Again, in a combination, order does not matter. All right, a combination is a grouping. How many groups? You're counting groups. A permutation is an arrangement. How many arrangements are there? They're a little different. When we talk about combinations, we'll say like, from 6, pick 3. A permutation, we say, from 6, arrange 3. Okay? Again, in a combination, order does not matter. Combination is a grouping. Permutation is an arrangement. And you can think of a permutation as an ordered combination. The permutation is an ordered combination. All right, as an example, how many groups of 3-digit numbers can we write using the digits 1, 2, 3, 4, and 5? Well, I wrote them out right here. What is that? That's 10. There's 10 ways to do it. They're right there. That's the groupings of 3. All right, here's the formula. From 5, just pick 3. From 5, pick 3. All right, here's the formula. Again, it becomes 5 factorial over 3 factorial times 2 factorial. All right, we end up with 10. That's the answer we got. Okay. Example 2. How many different ways are there to choose a committee of 2 from a list of 8 candidates? All right. This is from 8, pick 2. So again, our formula, 8 factorial on the top, 2 factorial on the bottom, and 8 minus 2 factorial. That's 6 factorial. Again, 6, 5, 4, 3, 2, 1 cancels out. So we just have 8 times 7 on the top and 2 on the bottom. It's 28 is the answer. Okay? You know, these are very similar examples to what I had in the first video. This is from 7, pick 4. All right, from 7, pick 4. Answer was 35. Okay? Again, just put it in your calculator. You can see that 6 times 2 here equals 6. Or 3 times 2 is 6. So this is just 7 times 5, 35. All right, here. From 4, pick 4. This is 4C4, or 4 combination 4. There's only one way to do that. You pick all 4. All right, order doesn't matter. So you're just picking all 4 of them. There's only one way to do that. One group of all of them. Okay? The second one, from 4, pick 1. From 4, pick 1. Well, guys, there's 4 ways to do that. You just pick 1 each time of the 4. All right? There's only 4 groups of 1 from 4. And again, I also want to show you that from 4, pick 3. 4 combo 3 is equal to 4. All right, how many groups of 3 can I make from a group of 4? I can just take 1 out each time. So that's 4 groups. I take 1 out each time. Okay? Again, just to summarize, a combination is a grouping or subset of items. For a combination, the order does not matter. This is the number of items in a set. Sometimes I write it like this. And this is the number of items selected for the group. And again, sometimes I write it like this, NC. Just remember, the first number is always the bigger number. The second number is the subset of the first one. Okay? Guys, right now, please the vocabulary. If you haven't done it yet, go ahead and do it. We just probably did it in Zoom. Guys, you've watched the video, huh? I guess I can get rid of that. Complete the exit ticket. That's all you have to do. Okay, it's in the bottom green folder. Good luck. Thanks, you guys. If you need some help, just email me.